Okay guys, welcome back to part 4. Part 4. And we were looking at what conditional permutations in the last video, and we are going to just continue with that. Okay, so let's chop the board off. This is where we were in the last video. Take it off. Okay, so for example, if we are asked to find the number of ways, let me look at the question very well. The number of ways in which the letters of the word shallow. So let me just write the word. The letters of the word shallow, they are arranged if the first condition is that the two L's must always be together. So the L's must be together. So there's the first condition A, and that's what we want to solve for. First of all, let's find the number of ways of arranging the letters of the word shallow. So we have 1, 2, 3, 4, 5, 6, 7. So our n over b factorial is going to be 7 factorial over the L's are 2, right? So 2 factorial, and that should give me, where's my calculus, 20 ways. Now let's consider the first condition when the L's are together. So I'll get, when the L's are together, the word shallow becomes something like this, shallow. So I'll get how many ways here? 1, 2, 3, 4, 5, 6. Okay, so that's going to give me 6 factorial over what? That's going to give me 6 factorial over what? No, I'll not get over anything because there are no identical elements again. So I'll just take it over. So that will just be what? Only 6 factorial. Don't forget, in part 1 we were learning how to what? Arrange the number of ways you can arrange the letters of a word when there are no any identical element. And we look at the word math. So you can check that video and see. So this is just 6. So 6 permutation, 6. So that's going to be something like 6b of 6, and that will give me 6 factorial direct. Alright, so the 6 factorial should give me what? 720. Now this is the first part of the question. You have answered it correct. When the L's must be together. B, the B says that you should find the number of ways of arranging the letters of the word shallow if the L's must be separated. If the L's must be separated. So if the L's must be separated, what does it mean? Now we know the number of ways of arranging the letters of the word if the L's are inside, the double L's. And then we also know the number of ways of arranging the letters of the word shallow when the L's are together. So if you want to find the number of ways of arranging the word letter when the L's are separated, we just subtract this value from this value. Then that gives us what? When the L's are separated, because we have the L's together and we have the total number of ways. So we subtract the two together from the total number of ways. That will give us the separated, because the separated and together should give us the total. That is what it actually means. So straightforward, let's jump straight in. Let's just chop this part off because we are done with together. So to get this type, we are just going to get 2520 minus what? 720, and that should give me 2520 minus 720. That will give me 1800 ways. So in 18008 ways, we get what? The L's being separated. Okay, so that's how we deal with what? Conditional probabilities. Now there are other I said conditional probabilities, conditional permutations. There are other ways we can arrange items or objects or people using what? Permutations. And that's what we'll be looking at in the next video. Now we look at case 1, case 2, case 3, and we also look at conditional permutations. Now we are going to look at what? The types of what? Cyclical what? Permutations. So what do I mean by that? The types or the cases of what? Cyclical permutations. It looks like we have a lot of formulas here, but I guess my students are good, so they will catch up. Okay, we are going to look at what? Cyclic permutation. So we're looking at cyclic permutation in details in the next video, in part 5 of this video, of the permutation video. So we'll be looking at cyclic permutation. So let me just give you an example of case 1. So case 1, when the number of ways R object choosing from n different objects can be arranged in a circle. So in how can we arrange R different objects chosen from n objects in a circle form, or the number of ways R objects chosen from n different objects can be arranged in a circle is given as n factorial over n minus R, all factorial times R. So this is just the formula for what? N permutation R, and you just multiply the down by what? R. That's all. So when you chop up this part, this is just the N permutation R. That's all. Then since they are in circle, you multiply by what? The R. That is all. So this is the case 1. So we'll solve some examples and you see how it goes. So this is the case 1 of the cyclical what? Permutation. So guys, I'm just giving you a gist of case 1. We'll look at all the cases in the next video. Okay. So guys, please, if you have not subscribed, hit the subscription button. Please, if you don't understand anything, alert me in the comment section. Like, share the video to your friends who are still in need. You know, some of your friends still need this video. It might help a friend somewhere. So please like and share, and let your friends also know what you are also studying from this video. Okay, thank you guys. See you in the next video, where we'll continue with what? All the cases. We have about how many cases to look at? 4 cases to look at in the cyclic permutation. Okay, so keep updates, focus, and we'll learn together. Okay, all right, see you guys, bye.